I guess the first thing I want to really put out for everyone here is what we do is we advance the internal combustion engine. And there is a misperception in the world that the internal combustion engine, whether it be diesel or gasoline, has gone about as far as it's ever going to go. And the answer to everything now will be electrification and so on and so forth. And that is very promising. But there's going to be a lot of new engines still put out there. There's a monster amount of legacy engines in the field at the ports that are going to be producing, emissions for years to come. And there's a lot that can be done in the very, very near term here to reduce those emissions and make those engines run other fuels. So that is what we do. We've been a R&D development company that licenses IP, but we now have become a production company. In particular, one area is an engine controller, very advanced engine controller, which DRS is the lead customer on it. Tony will speak briefly about how then he is using our technology to bring that to the field. Here's our facility here. I won't go through all of this, but we have all the capabilities to take any idea that has to do with the engine from an idea that we come up with in our sleep to proof of concept, through simulation, to analysis, to prototyping, to fully testing it in a dyno facility. Brief history on the company. Our founder, Eddie Sturman, still active in the company today, developed the digital valve for the Apollo program. He was inducted into the Space Foundation Hall of Fame for that activity. He was given partial credit for bringing the astronauts home safely from the Apollo 13 mission. Then over the years, we've taken that digital valve technology that he invented for the Apollo program and applied it to other products, mainly in the automotive sector. One I'll point out in particular, I don't know if the mouse is showing, the fuel injector here, that has the digital valve at the top, and then our other technologies continue to use that digital valve. Here's a quick look at the sorts of companies that we currently work with. Obviously academia, I work closely with Michigan there, and then the military has been a real focus of ours for many years, as well as other research entities and private sector companies. Now the things that we do aren't necessarily something that we would directly walk into the ports and say, use this. This is, a lot of our products are stuff that we have to go to companies that then do business with the ports. For example, if you use this, look at this fuel injector on the right, is a very large fuel injector. That's the kind of fuel injector that someone like Wärtsilä or someone like that would use. But that is a game-changing fuel injector as far as using lousy type bunker fuels, yet getting really low emissions when you pull into these ports. Another example here is, to give you guys some background, a natural gas engine usually gets about 27% efficiency. A diesel engine gets 41% efficiency. So if there's an interest in the ports to move from diesel engines and make those run off of natural gas, historically, you're going to lose a lot of efficiency when you do that. We won a $1 million grant from the California Energy Commission in Sacramento to show that with advanced engine technology, you can get all that back. You can get 41% engine efficiency out of natural gas. So this is a real game changer, something that I think is the sort of thing that could be implemented at this port to great advantage. Another, I wasn't directly involved in this program, but the Texas Environmental Research Council, we won an award from them too, to show, can we do a really low Nox calibration for drayage trucks and ports in Texas? And we successfully demonstrated there is definitely a way to do that. Now this was still running on diesel, I believe. But nonetheless, the Nox reduction that they wanted. Another misperception that's out there is an engine controller is an engine controller. That all the modern engines today obviously need a computer to run them, and that they're probably all pretty much the same. That couldn't be further from the truth. This engine controller that we have developed, which we call the Sockeye, which was kind of a branding fun thing that we've been through. That is probably, I would say definitely the most advanced engine controller in the world. This engine controller will run diesel, it will run gas, it will run natural gas, it will run biomethane, it will make any engine that runs any of those fuels run better. So the idea of the alternative fuel industry just pushing their fuels into the existing diesel and gasoline engines and just expecting them to burn however, that's over. There's a way to do it and make those fuels run better. Just mentioned that. One quick example before I turn this over to Tony. I know that this isn't an engineering crowd, so this is a very different experience for me today. But what I'll explain is this. If I can get my mouse to work here. Open loop. Just take my word for it, that's how most controllers work today. If you run biodiesel in a typical diesel engine today, what will happen, if you run regular diesel, you'll get this red line at the top. You'll get a lot of power out of that engine. If you put biodiesel into that same engine, you lose a ton of power, the blue line here. What our controller does is it has this closed loop functionality. And what that does is it makes biodiesel put out the same amount of power as diesel. So you're gonna gain efficiency, you're not gonna lose your power, which is why you can see that this program here was funded by the United States military. But all of our work has been military, really focused towards the military. But what we see and what he sees is the things that we've been doing can be greatly beneficial to the commercial market, and particularly here in California, which is where we are starting our campaign to try and help this state.